Hi everyone, welcome back to our maths classes with a new topic sequence, another topic in our revision booklet. So let's get started. So first question comes is what are the sequence? So sequence is a order that is a set of usually a numbers. So each number in the sequence is called the term. So this will be a definition. The number sequence is a set of numbers that follows a particular pattern or rule to get from term to term. Okay? Now sequence usually help us to describe the real life scenarios actually. So for example, how can we, understand the growth and decay of any product or the business or and everything. And especially with these growth and decays, we can always predict the pattern using the sequence and calculate when something will happen, right? Now, before moving forward, we need to understand the sequence vocabulary. So for that, when these numbers set of numbers are given, so the entire set of these numbers are known as sequence. But if the other numbers been separately answered, they are always known as the terms. Okay, and they can also be called as the first term, second term, third term, fourth term, and fifth term. Okay, likewise. So what are the types of sequences usually we work in GCSE or IGCSE? There are actually four types of sequence. Number one is the arithmetic. Second one is geometric, third is quadratic, and fourth one is a special one, which is a compilation of the 3, 4 sequence altogether. Now let's start with the first one. So first is the arithmetic sequence. In arithmetic sequence, each term is the sum of the previous term and the constant. Okay, they are the constant numbers. So for example, let's find the first term of the common difference of each. Okay, here's the question given. So 4, 9, 14, 19, and 24. Now, here the first term, I'll just give it a name called A is equal to 4. Okay, that's our first term. Now, my common difference here will be the second number in the series, okay, minus the first number. So, A2 minus A1 is going to give me the difference of these numbers, which is 9 minus 4 is equal to 5. Similarly, for the second one, so first number is my 34. Okay, that's my A. And the difference which I'm going to find is minus 7, which is 27 minus 34. So that's how I'm going to get my minus 7. You should always be careful, okay? Like means always check to make sure the difference is the same between each term. Then only it is an arithmetic sequence. Now, in this arithmetic sequence, the first term of arithmetic sequence is always A. We add D, which is the difference to get the next number. And there is always a pattern. So therefore, there is a formula we can use to, just use any term that we need without listing the whole sequence. And usually we call it a explicit rule. So what is the formula? Formula for the nth term in the arithmetic sequence will be like this. An is equal to a1 plus n minus 1 d. Now here an is the nth term which I'm talking about, okay, which I'm going to look for. A1 is always my first term of the sequence. N is always the nth term minus 1. Okay, the term which I'm looking for, minus 1, that is the position of the term, and the D, as we all know, the difference. Okay, the common difference in the arithmetic sequence. Now here, let's take this example. Find the 14th term of the arithmetic sequence. So here the series is given as 4, 7, 10, and 13. Now I need to find the 14th term of this arithmetic sequence. So what are we looking for? The term. All right. Now here the formula is an is equal to a1 plus n minus 1 times t. I will start substituting my values as per the formula given. So an is my 14. This is the term we are looking for. A1 is the 4. That's my first number in the series. And then 14th is the term which I'm looking for, minus 1 times by the difference. So as I can see, if I minus 4 from 7, I get the answer as 3. And this is the constant number which I'm getting with all other numbers as well. So that's the common difference. And start substituting the values. And this is how you're going to get the answer. And always remember you have to go as per the bid mass. You cannot just start working the way you want to. Okay. And the answer for the 14th term in the sequence will be 43. And this is how I'll find the answer of my 14th term in this series. Now the third term which we are going to find out is, second term which we are going to find out is geometric sequence. In the geometric sequence, each term is a product of the previous term and it is a constant. So in geometric sequence, okay, you'll find the product of the previous term and that will remain the constant of all the terms. So let's take the example here. What is the next term in this sequence? Suppose the sequence is given here. What is the rule of the sequence? And what is the seventh term of the sequence? So 3, 6, 12, 24, and 48. In this case, as I can see, these are jumping every times by 2. Okay. Now, times by 2. So my next term in the sequence will be 46 after the 48. The rule of the sequence is that they are multiplying by 2 each time. Okay. And the seventh term in this sequence is going to be 192. Now you'll be wondering how. Okay, so let's see. The first term, 3. Second term is 3 times 2. Fourth is 3 times 2 times 2. All right. So every single time the first number is multiplying by 2. Okay. Now 3 times 2 times 2 times 2. And the fifth one is again 3 times 2 times 2 times 2. Okay. So it means 4 times you are jumping. Okay. 4 times timesing it with 2. Now, rather than writing all these things, we can also write this in a very simplifying way, which is 3 times 2 to the power 4. So here, if you have a knowledge of indices and exponents, you can always use it. And the nth term is going to be a times r. R is my multiplier, a is my first term, n minus 1. N is the nth term minus 1. So if suppose they are asking seventh term, so 7 minus 1, which is going to be 6. So that will be the value of your exponent or the indices. Now, geometric sequence again is one more question given here. So here the nth term given and the formula is a times r n minus 1. So the sequence is given here 4 minus 8, 16 and minus 32. What is the rule of the sequence here? So multiplier is minus 8 divided by 4. Always remember, my second term is dividing by the first term to find the difference between them. Okay, so here it is minus 2. So first term is 4 and 4 times minus 2 n to the power minus 1, okay, will be my here. So if I have to find the seventh term in the sequence, it is going to be 4 times minus 2 to the power 6. Why? Because I'm finding the seventh term, minus 1 is going to give me 6. So 6 will be my indices here. And the answer will be 256. This is how the geometric sequence work. Now for find the nth term for each geometric sequence, use the formula to answer the question. So here are some questions given. If you feel confident, video and try to find the answer by yourself. So here are the answers for you all. Okay. Now next is the quadratic sequence. A quadratic sequence is linked to the square numbers. Always remember. Okay. And the first difference is not constant, but the second difference is constant. So for example, let's take this example. Find the next two terms of this quadratic sequence. So here the sequence is given as 1, 4, 9, 16 and 25. What we're going to do here is first we'll find the difference in these two. So I can see the first difference is not at all the constant. So what I'll do, I'll find the second difference. So in that case, I can see my second difference is always, is the constant one. Now the sequence is going as plus 3, plus 5, plus 7, plus 9, and the second difference is going always as plus 2. Now, what we're going to do from this information, we can work out the next two terms. And that will be, so if I have to add from plus 9, if I add 2, it will be plus 11. And if I add plus 11 in 25, I will get 36. Similarly, from there, again in 11, if I add plus 2, I'll get plus 13. And in 36, if I add 13, I'll get 49. So this is how I can find my quadratic sequence. Because these are the square numbers, the n term is n square. Always remember that. Let's take more examples of it. So find the nth term of these quadratic sequence: 8, 11, 16, 23, and 32. And second one is 2, 12, 34, 62, and 98. So in that case, here are the sequence. And the second difference is 2. So 2 divided by 2 is equal to 1. And that my n square, as I told you. So n square is equal to 1, 4, 9, 16, and 25. Similarly, 8, 11, 16, 23, and 32 you got because they are adding plus 7 each time. Okay, and this is how I'll find my nth term is n square plus 7. Similarly for the second one also, plus 12, plus 20, plus 28, 36. Second difference is 8. It means 8 divided by 2 because it on the second difference. And the fourth is my nth term. So it means n 4n square. It means n 4n square is equal to, 4, 16, 36, 64, and 100, which is going to be every time they are into the minus, which is minus 2 each time. And the n term is going to be 4n square minus 2 here. Okay, this is how you need to find the answer for the quadratic sequence. Now, there are some special sequence as well. And you'll need to be able to recognize some important special sequence. Square means like a square numbers. First one, and let's take the numbers, and the square number is a result when the number is multiplied by itself. Okay, so for example, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. So these are the square numbers. And you'll find you must have seen these kind of questions in your exam. Now, in this case, the square number can form a sequence, which is 1, 4, 9, 16, likewise, which are the square numbers. So the n term will always be n square here. Okay. Now, second is cube numbers. What are the cube numbers? Cube numbers is a result when the number is multiplied itself 3 times. For example, 1 times 1 times 1 is 1, 2 times 2 times 2, and 3 times 3 times 3, etc. And you will find these kind of, you must have seen this picture most of the time in your exams. Okay? And when you see these kind of pictures, the cube numbers can form a sequence, which is 1, 8, 27, 64, and 5. And the nth term will be n to the power to 3, which is cube. Okay? N cube. Now, next is triangular numbers. What are the triangular numbers? They are the numbers that can form a triangular dot patterns. And they're also special type of quadratic sequence. You must have seen this picture. Okay. Now, in this picture, we can generate a sequence of triangle numbers by adding one more to the term to term rule each time. Okay. And in that case, 1, 3, 6, 10, 15. So it is every single time they are adding plus 2, then plus 3, and plus 4, and plus 5. Okay, it's a term to term rule. Now, next is the Fibonacci numbers. Fibonacci numbers you must have seen in your arts. Actually, you must have learned about it. Fibonacci is a very special. We can generate the Fibonacci sequence by numbers, also by adding the previous two numbers together to work out the next number. And the first and second number, we can start with like first and second terms. We start with 0 and 1 always in Fibonacci, and 0 plus 1 is 1, and third number is 1. Okay, because it is 0, 1, and 1. Right, now the fourth number will be 1 plus 1 is equal to 2. Sequence will be 0, 1, 1, 2. And then fifth term is going to be 1 plus 2 is 3. So the sequence will be 0, 1, 1, 2, 3. This will be the sequence for the fifth term. So we can continue the following pattern to generate an infinite sequence here. And you have seen these kind of patterns in the art. Again, I'm repeating it. And they are very, very special Fibonacci numbers. Now, Fibonacci numbers, when we are talking about in sequence, so for example, you have been given these numbers. So this is the sequence given. And now Fibonacci sequence forms a spiral that is, seen throughout the nature like this. You must have seen it. Okay, these kind of pictures are the example of the Fibonacci sequence. Now, there are some application of the sequence which you all need to remember. Sequence have real world application such as calculating compound interest, population growth, and Fibonacci sequence. Compound interest can be molded using the geometric sequence. Plus, for population growth can be molded using an exponential sequence. And Fibonacci sequence appears in the nature and art. So these are the application of the sequence. You all have to remember that. Now we have the summary. So what we have learned here is we covered the arithmetic, geometric, and quadratic sequence, especially here, along with the special sequence. And you all have to review the key concept and formulas covered in this video. Now the conclusion is sequence are an important concept in mathematics and have a real world application. So students, you all should practice applying their knowledge of sequence and seek help if they have any question. Okay, you have to reach out to your teachers or practice the question, then only you'll be able to master this topic. Thank you for watching. We hope you found this video informative and helpful. Remember to always break down the problems, use logical and critical thinking, and check your work. Practice makes perfect, so don't be afraid to tackle similar problems. If you have any further question or need help with a specific problem, please don't hesitate to reach out to us. Thanks again, and we'll see you in the next video.